Hello, in this video I will show you my solution to Milestone 3 of the Minesweeper coding challenge. If you haven't seen the description of Milestone 3, check out the link to the video in the description. And also, if you have no idea what I'm talking about, but you would like to code Minesweeper with me, check out the link to the playlist in the description. And start with Milestone 1, of course. So in this milestone, what we did was we added these two things, which look very similar. This one counts how many bombs are left on the board, are left unmarked on the board. And this one is a timer that starts counting, or a stopwatch that starts counting once you expose the first cell. So as you can see, they don't work. They are just there for show. They're pretty, they're nice. And in the next milestone, we'll make them work. But they do work in the sense that if I go into the code and I enter hard-coded numbers, I enter different numbers, they show all the numbers correctly, like the real game, from -99 all the way up to 999. And I'll show you that in a minute. So let's take a look at the code. So before I show you how I implemented the counter component. So basically, this is the counter component, and this is also a counter component. So I reused it, and as you can see, I gave it a prop value of 7. So let's see, if I do -99, how will it look? Looks good. If I do -3 or -2, see, this is how the real game looks. It's a minus, and then a 0, and then a 2. And here, I'll show you. Sorry, I'm not yet good with switching windows. So this is the real game. So if I just flag lots of things, and I get to 1, I get to 0, look at how the minus looks. -0, 1. That's how it looks. So I did it just like the real game. And let's see other options. So what about 0? So 0 looks like 3 zeros. That's good. What about just a one-digit number, so 4. That looks good. What about like a 2-digit number, like 54? Looks good. And let's do 999. Looks good. So test your code as well to make sure that it works. And basically, once we have this milestone down, all we have to focus on is to give the correct value to the component. But building the component has nothing to do with the logic of giving it the correct value, right? So I love splitting, any coding tasks to these. You can call them baby steps, you can call them milestones, whatever you want. And that way, divide and conquer, and a really complex task, which seems daunting, becomes doable. So enough of my rambles. There's one thing I said I'd show you, and I didn't last time. And it has to do with styling. So I want to do that now because I'm going to forget. So remember, I told you about REM, right? Why am I writing the things in REM? Okay, so I did a bit of a hack here, okay? I specified the font size of the root component, or the root element, and I wrote the following. This affects every unit that is specified with REM. Change this to scale the entire game. So REM is basically taking the font size of the root, and multiplying it by this number. So that way, if I write 1 here, and I refresh, and I scale it down, reset, this is the size of the game. And if I do 2 here, it looks twice as big. If I do, let's say 5 here, it looks huge, okay? So I wanted this control. Why didn't I just use scale? Well, because when I used scale, I had these tiny, tiny rendering issues where you saw these gaps between the cells. I might go back to using scale, but for now, this is what I did. Because I want the default zoom to be however much I want it. I don't want it to be like this teeny tiny game. Okay? So for now, I did it like this. So it's basically twice as big as the actual size of stuff. Okay, now back to the solution for milestone 3. So we saw that, okay, let's just go over the components again. So we have the app, which is the root component, and it just renders the game. The game component renders the beveled box, which is basically the outer styling of this thing. And inside of it, you have the board top bar and the board. So this is the board top bar, and this is the board. And what we did was we added these two things to the board top bar. So let's look at the board top bar. And it is also inside of a beveled box that is inset, right? Look at this beveled box. Just wonderful. See how clean the code is? See how nice it is to like take things out, refactor things, factor them out. Don't just hack them together. So inside the beveled box, we have a counter, we have the smiley button, and we have a counter. So this is the first one, then the smiley, then the counter. It doesn't matter that this one's going to count bombs and this one's going to do a stopwatch. It doesn't matter. We'll handle that in the state. But for now, it just displays hard-coded values. All right. And now let's look how the counter is implemented. So I forgot to mention that I have prepared the SVGs. You have the minus SVG all the way up to the 9, from 0 to 9 SVG, which is each digit. So basically, the counter component renders 3 images, each of which is the correct digit. So basically, each image has a source of counter slash, let's say 1 SVG, 5 SVG, right? So the only thing we need to figure out is which 3 digits need to be displayed for a given value. And that depends, okay? So what I ended up doing after a little bit of, fudging the code and seeing how best to write it is as follows. First of all, I took the value and I changed it to positive if it was negative. So if it's -2, it's going to be 2. And then I added a padding of 0 at the front. So if the number is a 2-digit or 3-digit number, then this does nothing. But if the number is a 1-digit number, it adds a 0 at the front. Okay? You want to see it? Let's do console log. And I didn't know how to do this. I just Googled, how do I pad, blah, 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 blah. Okay, so let's do console log of values string. Let's do this like this. Okay, and let's see what we get in the console. We'll probably get 2 of them, right? Okay, let's erase this. Ooh, look, I forgot to add a key prop. I always forget to add a key prop. Yeah, it's always good to open the console. Anyway, I'll fix that in a second. You know what? Let's fix it now. So where did I forget? I forgot in map, right? It's very easy. Key equals IDX, right? Problem solved? Yes. Okay, so as you can see, value string is 999 because padding, let's do like this. Value, and then value string. So if the value was 999, the value string is 999. Like I said, if the value is a 1-digit thing, like 0, the value string is just added, like you get an added 0 at the front. And let's try another number. Let's say we do 4. So the value string is 04. And if we do -4, it'll also be 04 for now. Okay? That's what I wanted here. Okay, that's what this did. It added a 0 in case the number was anywhere between -9 and 9, and it took off the minus. And now I go like this. If the value is less than 0, so it's a negative value, I want to prepend it with a minus. So it'll be -04, right? If it was -4. Otherwise, it's not a negative value. I want to check, is the value less than 99, less or equal to 99, which means the value is anywhere between 0 to 99. Then I want to prepend it with a 0. That's all, we're done. That's it. Now we have value string, which is a string with 3 characters, for sure, a string with 3 characters, and the digit that we want to get is either in the 0, the 2nd, or the 3rd index of that string, and then we just return the correct SVG, and we're done. We got a value, and we rendered 3 images that represent that value. Here, -0.4, right? That was a lot of fun to write. And again, how beautiful is that we reuse the beveled box? How simple, how beautiful. And the beveled box is inset, and the bevel width is just a teeny tiny 1, okay? It's very, very tiny, 1 pixel. And this is what the corner of it looks like. And obviously, in order for that to work, I had to create a border or a corner, which is called corner 1 inset, because bevel width is 1 and inset is true. So this is just a very simple SVG. You can grab it yourself from the repo, and that is the counter. Isn't it awesome? Let's look at the CSS for the counter. Very clean. Why is it very clean? Because of the beveled box. The beveled box, look at how much work the beveled box is doing and redoing for us. We don't have to copy paste this stuff. Look at how simple it is, how clean it is. So let me tell you why I did this. I did this because it's a hack. If I take it off, there is sometimes a glitch when you resize, and sometimes you can see a little sliver here. And so I added this in order for that sliver to be less visible. And finally, I set the height of the digit image. So basically, this is a digit image. This is a digit image. I set it to be the height of the counter size, which I defined in the variables. So I have the cell size, it's 16, basically 16 pixels, smiley size 26, counter size or counter height would be more correct. Let's change it. No, let's not change it. Let's leave it. Counter height would be more correct. Let's change it, even though I will have to remake the branch and everything, but let's do it. Let's make our code look good and sound and not confusing in any way. Okay, so this is the counter height. Why do I have background repeat? Why do I have this? Was I sleeping when I wrote this code? I don't know. There is no reason for that. It's not a background image. It's a real image. Okay, well, that got the code a little bit cleaner, but you can see pretty clean. Now, what else do I want to show you? The last thing I want to show you is that I made the game a bit bigger. Why? Because it was small, and then it looked funny, and now the top bar is larger, so I wanted the game to also be larger. This was really simple. I just, went into the game service and just added a few more cells to the solution. I tried to make them correct. I may have been wrong. And all the cell states are uncovered. Obviously, this is hard-coded, and we're going to change it, so who cares that, we don't have to make this look great. When we randomly generate the board, this code will be erased, so who cares how it looks? For now, it is good like this. So as you can see, Milestone 3 wasn't that hard, was it? So I think that Milestone 4 will be to make these guys actually work. And I also think that it's time to make the game recognize that the game has been won. So basically the smiley becomes sunglasses once you've exposed all cells that do not contain a bomb. So I think that'll be Milestone 4. We'll talk about it in the next video. Let me know if you liked my solution, if you think you can do it better, if you learned from it. If there was something that you'd like me to explain, I'd be happy to. And I think that's it for this video. So see you in the next one.